Hi guys, this is Khushbu and welcome to Algorithms Made Easy. In this video, we'll see the question deepest leaf sum. Given a root of a binary tree, return the sum of values at its deepest leaf. For this first example, you can see we have 3 leaves, 7, 5 and 8. From these 3, we have 7 and 8 at its deepest level. And so, the sum of these values is our answer, which is 15. Similarly, if you would see for the second example, the answer would come out to be 19. Now, the constraints given with this problem are that the number of nodes in the tree would be in range of 1 to 10 raised to 4 and its value would be 1 to 100. There are 2 hints given with this question, which says that firstly you can traverse the tree to find the maximum depth, and the second hint says that traverse the tree again to compute the sum required. So over here they are trying to tell us that we can find out the solution for this in 2 parts. First is finding the maximum depth and second is computing the sum at that particular depth. So let's quickly go and write down the solution that they are trying to tell us, and then we'll try to optimize it further. So how do you find the maximum depth? If you are not aware, you can go to the video that we have already created on this topic, the link to which is in the top and also in the description below. So over here, the first method that I'm going to write down is to find the maximum depth. So let's take an integer max depth, and over here I'll simply call a method on this root to find the max depth. Now let's write down the method for that. So this method will return an integer that would denote the maximum depth of that particular tree. Now, if the node is null, my depth would be 0. Otherwise, my depth would be the maximum of left or the right depth. And to add in the current level, I'll be adding 1 to that depth. So, I'll be doing 1 plus maximum of max depth of left node and right node. So this would give me the maximum depth of that tree. Now that I have the depth, I need to find the sum of the values of the nodes. So for that, I'll take another method and then calculate the sum of those nodes at that maximum depth level. So for that, let's take a global variable sum that would be 0 initially, and then we'll be updating this sum. Over here, I'll now find the sum for my tree at my max depth, which is equal to this max depth that I have found out, and finally return the sum. Now what I need to do is find the sum. So I'll write this method which will take the node and the depth at which I will need to find the sum. So over here, if my node is not equal to null, then I'll check whether my current depth is equal to the maximum depth or not. So for that, I'll also pass in the current depth. So root would be at depth equal to 1, and over here I'll specify my current depth. So if current is equal to the depth that I am requiring, I'll be adding that in the sum value. So my sum becomes sum plus node.val. Otherwise, I'll just keep on finding the sum for the lower levels. So for that, I'll call find sum on node.left, current plus 1 and the depth, and similarly for right. So this 1 is to add the current depth because you are going 1 level below that. And that's all. Let's try to run this code, and it's giving a perfect result. Let's submit this. And it got submitted. So the time complexity for this particular solution would be going on over the tree twice, that is O of 2n, and the space complexity is O of 1. Now, is there a better solution for this? Is there a way we can reduce this 2n to a single iteration? That is, I do not want to calculate the max depth, and so I'll be commenting this thing out, and with this, there goes my calculation. Instead of that, I'll be taking a variable that would be max depth over here, and I'll do a find sum. Now inside this find sum, I also need to check whether this is the maximum depth or not. So over here, I'll see whether my current level is greater than the level that is present in my max depth, then I'll update this max depth and make my sum to 0, because the previous sum that I was having was at some level that was not actually my max depth level. So I'm making my current level as maximum depth and I am making my sum as 0. Now, there should be a point wherein I am actually adding that particular value into my sum. So now again, I'll check whether my current level is the max depth level. If yes, I'll add the node's value in my sum. And over here, I'll just colon on current plus 1. So this would solve the problem in just O of n and not in O of 2n time. Let's try to run this code and it's giving a perfect result. Let's submit this and it got submitted. So over here we have saved one iteration on the tree. So that's it for this video, guys. I hope you liked it and I'll see you in another one. So till then, keep learning, keep coding.